In this lesson, Chapter 1.8b, we are going to be using another property called the distributive property. In the distributive property, yes, it's a powerful property, but it can be confusing, so you're really going to have to pay attention. If we would see the problem 3 times the quantity 2 plus 7, the order of operations would tell us to add the 2 plus the 7 first. So if we were going to simplify it using the order of operations like we had the other day, it would be 3 times 9 and then equals 27. However, and this is where the distributive property comes in, 3 times that quantity 2 plus 7 is also equal to 3 times 2 plus 3 times 7. The distribution part of this is to take the 3 and distribute it to the 2, and then to take the 3 and distribute it to the 7. Notice that we keep the addition sign. So 3 times 2 plus 3 times 7. Now if we're going to simplify this, 3 times 2 is 6, plus 3 times 7, which is 21, and then we can add to get 27. This is an example of really using this distributive property. Now the property can be used with multiplication and addition, or with multiplication and subtraction. It's one of the very few properties we have that can be included with, or that can be used with subtraction. If you noticed the other day with commutative property and associative property, all we did was addition and multiplication. This one has a subtraction to it. If we look on the arithmetic side, this is a repeat of what I had in the very first example at the top, 3 times 2 plus 3 times 7. Now, 5 times 8, there I'm distributing. Here's that subtraction sign. Here's the subtraction sign. Now I need to take 5 and distribute to the 2, and then 5 times 2. This one is used quite a bit in algebra. So if you'll notice, you can take A times B. That's the distribution, to take A times B. Yes, I get my product called AB. Here's addition. Here's the addition. Then I take A, distribute to the C, and I will get A times C. A times B, A times B, minus A times C. Okay, finding the products. Now I'm going to use it. 5 times the quantity k minus 4. I am going to distribute the 5 to the k to get 5 times k. Subtraction sign, subtraction sign. 5 times 4 to get the 5 times 4. Now I need to simplify. 5 times k is just going to be 5k. Again, the subtraction sign. And now I do the multiplication for 5 times 4 is 20. This is in simplest form. This is the best I can do, is to take 5k minus 20. Sometimes they will put the multiplier, the 9, in the back of the quantity instead of in the front of the quantity. It's the same thing. We're going to take 9 times n. That's 9n. We have a minus. Then I'm going to take 9 times 2, 9 times 2. Now I simplify. 9n minus 9 times 2 is 18. And that is a simplified form. C. Now here's where you got to be careful, and that's why I've written the note out for you. This is a very important note. If the coefficient that means the negative 7. In A, the coefficient is 5. In B, the coefficient is 9. In C, the coefficient is -7. Notice, if the coefficient is negative and you have subtraction in the quantity, then you should probably change that subtraction to add the opposite before you try to do any multiplication. Otherwise, it's just going to make the problem a whole lot more difficult to do. Now we can distribute -7 times v. -7 times that v. Notice it's a plus sign now. -7 times -4. -7 times v is -7v plus -7 times -4 is going to be +28. There will be times when the quantity will be 4 minus the variable. We can distribute the same way. 3 times 4. This is subtraction, so I use subtraction. 3 times x. 3 times 4 is 12, minus 3 times x is 3x. Now here again, we're going to have a bit of a problem. Variables are first when we simplify. Because it's a subtraction, I would change it to add the opposite. And now we can use the commutative property because it's addition. So -3x plus 12. Let's look at E. See if you can figure it out on your own. So press pause and then I'll go over it. Let's see how you did. 2 times -6 plus 2 times y. -12 plus 2y. This is addition, so I can do the commute, and I want that variable first. 2y plus -12. Now, if you remember when we had the lesson on like terms, I mentioned that they really don't like to leave things as plus negatives. The correct simplification of this is to say 2y minus 12. Now what you have happening here is with subtraction, this would be add a -12. So if you see add a -12, that really means subtracting 12. We can use the distributive property with algebra with nothing but variables. N times W plus N times 4. NW plus N times 4 is going to be 4N. When we write these out, if you have a term that has 2 variables in it, they want the variables in alphabetical order, and they would like the 2 variables before a 1 variable term. How do we use a distributive property? Years ago, this was taught in school quite a bit. It was called the break apart, and it was used a lot for estimating. But you're going to have to learn how to recognize it. So when you look at something like A, ask yourself, what is repeated twice? What's on the left side of the addition sign? What's on the right side of the addition sign? The thing that's the same is the 15. So what we really have is 15 times the quantity 4 plus 6. That really means that we have 15 times 10, and now we can use mental math to figure out that it's 150. Look at B. What's on the left side of the subtraction sign that also occurs on the right side of the subtraction sign? It's the eighths. That's my coefficients. The 13 minus 3 goes inside the quantity or the parentheses. So it's 8 times 10 equals 80. Try C. Hit pause, and then we'll go over it. What's used on both sides of the subtraction sign is the 78. So 78 times the quantity 56 minus 46. That means 78 times 10, which is going to equal 780. Now before I mentioned that this is really done quite often with estimating, but it's also done with decimals. And like back when my mom and dad were in school, back in the 30s, 1930s, this was taught as a way to get to your answer very quickly. Remember, back in the 1930s and back when I was in school in the 1960s and early 70s, we didn't have calculators. So this was taught as a way to go about doing the problem and coming up with an answer. What we have is 3 books at $16.99 each. Now, $16.99 is really $17 minus a penny. 3 times 17, using our distributive property, is 51, and 3 times the 1 penny would give us 0.03 or 3 cents. Now it's pretty easy to do a mental math subtraction. What's 3 cents less than $51? $50.97. This parentheses over here, by the way, is a boo-boo that I have not been taking out. Let's look at B. What I really have is 6 times 0.98. 6 times $1 minus 2 cents, 0.02. Now we don't use the 2 because you'll be subtracting 12 and you're going to be in trouble because you're going to end up with 6 minus 12. So we have to use the decimal. 6 minus 0.12, well, 12 cents away from $6 is going to be $5.88. You try C, and then I'll go over it. The problem is really $2.95 times 5. That means we really have $3 minus 5 cents, 0.05. The distributive property says 5 times 3 is 15 minus 5 times 0.05, which is going to be 25 cents. Better get it right here. 25 cents. Okay, so what is 25 cents less than $15? Yes, $14.75. That will conclude this lesson, so scouting out.